Hello, I'm Juan, and I'm here to show you some equation formulas used on calculating the work and energy done through a spring based on its change in height. First, you will have a graph that will look somewhat like this based on your Logger Pro. This top graph will be your distance or ultrasonic sensor information, and the bottom graph will be based on your force sensor. Okay? What you will do is measure up to the point of the highest impulse in the beginning. This on the first graph will be your delta y, or your distance which that spring compressed. While in the bottom, in the force graph, you will have the maximum force that was applied to reach this compression. Okay? Now, we know that work is equal to force times distance. So based on your force, which you will measure right here, and your distance, which is the highest peak on this, this wave, you multiply that to get your work. Now, from this, you can move on to your next equation, which is your energy or conservation of energy equation, which is known as T1 plus or minus U sub 1 minus 2 is equal to T2. Now, we will expand this and use 1/2 mass times velocity squared plus your work times your delta y, which is equal to your 1/2 mass times velocity squared, which in this case we're going to substitute as T2. Now, your mass, you should have already calculated this by adding your weight, your force gauge, and whatever wire or string you use to attach it to. So that will give you your mass. Now, you will fill this in, which is 1/2 times the mass of what equipment you're using times the velocity squared. Now, velocity we could figure out by determining the time it takes, the time interval, to reach that highest peak. So let's just say in this case, we know that that time interval is 0.5. So we get our distance, or our delta y, over 0.5 to find the velocity. That velocity will be squared, and we'll add that to our work times our delta y, which is, like, once again, our work times our height, which will give us our kinetic energy. So that's the way you will solve the following by using these equations to prove that work and energy were done through the spring through a change in height. Based on what springs you use, these numbers may vary, but it is a solid way to prove that a spring will do work based on its change in time and height. I'll cut the last part.